this video, I'll be explaining how Contra ReBirth's physics engine works. We'll be taking a closer look at the game's mechanics, such as movement speeds, jumps, how the game calculates movement each frame, and truncation. There may be a continuation of this video as more discoveries about the game are made. Shoutouts to Revolving Madness, who I'll have linked below, who helped make some visuals for this video. He was also a key figure in looking through the game's code and sharing some of the game's variables with me. To start things off, let's talk about X velocity. X velocity is how fast a player moves left or right. There is no acceleration to worry about here, so once you press a button on the controller, after 4 frames of input delay, you move that character's X velocity in pixels per frame. It's been known for a while now that Pliskin has the highest X velocity, but nobody really knew by how much. But now we know that Pliskin moves an X velocity of 2 pixels per frame either left or right, and every other character has an X velocity of 1.75 pixels per frame left or right. In other words, for every 8 pixels Pliskin would move left or right, every other character, whether it's Bill, Yagyu, or Brownie, would move 7 pixels left or right. However, vertically, things are much more complicated. Before we can talk about Y velocity, we must first discuss gravity and drag. Gravity is an acceleration of 0.3 pixels per frame squared that gets added to your current Y velocity. Gravity is one of the first processes done by the game's physics engine. Now you may be asking, why is gravity added instead of subtracted? Now the answer in this lies in where the origin is in the game's coding. The origin, or 00, is typically located in the top left corner of the screen. Unlike a usual graph, negative locations for Y are located above this point and not below. The positive locations for Y are located below this point. We can think of gravity as a force that is weighing the character down. However, there is a limit to how much gravity can be applied to the character at a time. This limit is called terminal velocity. The terminal velocity in Contra ReBirth is set to 4 pixels per frame. This means that gravity will be applied each frame until a final 4 pixels per frame is reached. Now let's talk about drag. On every frame, drag is a constant that is taken away from any type of velocity. Specifically, on every frame, after gravity is calculated, 1/32 of any type of velocity is taken away. Now when looking at just the Y velocity of a jump, we can see that Brownie's is higher than the others because Brownie has a higher initial velocity when jumping. Brownie's initial velocity is set to 9.75 pixels per frame, while Bill, Yagyu, and Pliskin all have an initial velocity of 9 pixels per frame. That's why Brownie has a higher and longer jump than the other characters. Specifically, when Brownie jumps on even ground, she is airborne for 55 frames, while every other character would be airborne for 51 frames. Now let's go through the process starting from frame 1. The first thing the game does is account for drag. We can do this by multiplying the velocity before drag by 31/32. The reason we did drag first instead of gravity this time is because the only frame where gravity does not matter is on the very first frame of a jump. In every subsequent frame of the jump, 0.3 would be added before drag is applied. Now let's talk about full jumps. Before we get into this, note that each of these jumps starts at the coordinates 12, 440, as those are the coordinates of the farthest left corner of the debug room where the data was taken. One thing I'd like to immediately point out is that towards the end of the jump, you can sometimes lose frames on the little stutter. There isn't enough data to explain why this is, but in my experience, it seems to happen a lot. Anyways, let's start doing some calculations. Let's first look for the angle each character jumps at by splitting this into 3 triangles. These 3 triangles will represent each different character's first frame of Y and X velocity. Using trigonometry, we can find each character's resultant as well as each character's initial angle. Keep in mind that although these angles are negative, they still represent angles that are above the horizontal. Now let's use the initial resultant of each character to find kinetic energy. We can essentially disregard mass here because all of the characters' masses are equal. We can see here that Brownie exerts the most kinetic energy. Now let's bring back the triangles from earlier and let's observe what happens towards the end of the jump. We can notice that all of the Y velocities are the same because every character will have reached terminal velocity by this point. Here are the resultants after we do the calculations. Now we solve for kinetic energy again, and we subtract it from the initial. These new amounts of kinetic energy describe how much energy is burned. Well anyway, I hope I've provided new information and insight to you, which may or may not ever be useful to Contra ReBirth speedrunning. But that's okay. Even if it isn't useful now, it's still important that I log all the information I find out about this game on the chance it may one day be useful, or to bounce ideas off of others to figure out more things about this game. This is still my first non-speedrunning video on this channel. I hope you've enjoyed it, as it took me quite a bit of effort to figure out how to edit videos. Make sure to drop a comment if anything I explained in the video was too difficult to understand, or I just did a terrible job explaining. I'll be glad to look through all the comments and make sure you understand. I plan on sometime doing a Contra ReBirth guide video as well, just talking about everything a person would need to know to get into speedrunning the game. So if you'd like to see that, please let me know, and I'll be sure to do that. Thanks for watching.